So with this lecture, my goal is just to make us aware of certain conveniences. We've done many calculations on the board, we know how to do some things, but I don't want to every time go and do everything by hand. There are more convenient ways of doing these things. So let's look at example 1. I want to estimate the x-intercept or intercept for y equals negative x squared plus 2x plus 5. Now I know it's a quadratic function. It's a parabola. I can do the axis of symmetry and all that to find out what the shape is exactly, but I don't have to. I've done it once. I understand how it works. How can I just quickly see what does the curve look like? So let's go to Google. Google is my friend. And C, zoom out a little bit.
Help me graduate.
I'm going to type in negative x squared plus 2x plus 5. And it plots it for me right away. If I just want to see what does the parabola look like, it's right there. Google has it built in.
What's that thing?
Where?
The up thing on the square.
That is x to the power of 2.
Oh. What's a star mean?
Star means multiply. But you'll notice that I didn't have to put in the star. Google knows.
Oh.
Google knows that it's multiplying. And I can zoom in and out on this. Zoom in, drag it around, see what I want to see. In this case, I'm interested in the x-intercept, and I have x-intercepts, and I have 2 here. If I want to know, it's just an estimate. I can be reasonably accurate. It looks like around 2.5, but I can zoom in, and zoom in, and zoom in, and zoom in, and keep zooming. However accurate I want to be, and you'll notice here the little dot moving around. I can hover it over the x-axis, and I see roughly this is my x-intercept, negative 1.45. And I can zoom back out, zoom, zoom, I'm just doing it with the mouse wheel, move all the way over to the other guy. I know there's another x-intercept somewhere, around 3.5. You can zoom in on that, see, depending on how accurate I want to be, 3.45, something, just to get an idea. So I can very easily use Google to just sketch a curve for me. I can do it by hand, but I don't need to. And if I have something fancier, like let's say that's x to the power of 4 for some reason, now there's a lot of calculus involved in sketching this by hand. It's a lot. I don't want to do that. Google does it for me, and I can see, oh, okay, it has a little strange bend here, and I can see where does it intersect the y-axis at 5, and anything I want to read off. So there are convenient ways of just sketching a function and seeing what it looks like, and so on. Any questions on this? Just things today to be aware of, convenience things, really. I'm not going to ask you to do this in a test or a final or anything like that. We've done the actual work for phase 2 already. Let's read number 2. For the first years, the value of the stock changes according to that function over there, which is more than a quadratic function, so it'll be hard to do it by hand. P is the value of the stock, and T is the number of months. Use a computer if I want to, for convenience, to estimate when the stock would reach a value of 15. So I go to Google. Now I have a new function. Let's put it in. I don't have to put in P equals, just the function T to the power of 3 plus 2 times T minus T plus 4. Enter. And Google says, did I copy that correctly?
T to the power of 2.
I forgot the T to the power of 3. Minus T plus 4, okay, that's better. Now t represents the number of months, so I'm going to drag this guy over a little bit to the positive values. Zoom out a little bit, something like that. Now what do they want to know? They want to know when, for which value of t, will the y value or the p value equal 15. So I'm looking for this point over here. And I can zoom in there if I want to. Drag it a little bit. 15 is over here roughly. See how my coordinates change? Roughly over there, so I get a value of t equals 1.8 something. So roughly after 1.8 months, will I get a value of 15. It's just an estimate. It's more or less. Now, realistically, I guess this function rises very quickly, so it might not be very accurate as the months progress, but maybe for a small window, the stock value grows like this. And I can just look at how it changes and read off what I want to know. Any questions on this? Things to be aware of. I only recently become aware of Google's convenience and sketching things with very little effort. Let's look at number 3. I took an example that we did last time by hand. Let's see how we can do it. We know how to do it. We can now use things to make our life simpler. Estimate the equilibrium point if the supply and demand equations are of a product are those two equations. So if you remember, we did this last time. Let's see if I can put this in and Google can sketch both. And remember, I'm looking for the intercept. So on the one hand, I have Q divided by 40 plus 10. And the other one, I have 8,000 divided by Q. Is that right? Enter. Oh, nothing happens. It's because Google doesn't know what my Q is. If I use something more common, X is common, and T is common. Q is not that common. If I use an X instead of a Q, then it knows, well, okay, this looks a little strange, but let's zoom out and see what it does. It didn't know where to put the curve for me. It was zoomed in a lot. Let's zoom out and see what's happening. This does look familiar. I have my blue straight line, and my red curve that I mentioned last time actually has a piece over here, but I'm interested in quantity on the x-axis, so let's zoom in on this piece, and I see I have my demand curve in red and my supply curve in blue. I'm looking for the equilibrium point, which is where they intersect. I can just zoom in here and read it off. They intersect, it seems like roughly, now remember I used an X, but it represents quantity Q. When Q is around 400, and when the price, the Y value, oh, the mouse shifts a little bit, when the price is around 20. Which, if you remember what we did by hand, that was our answer. Q equals 400, and the corresponding price equal 20. But once I've done it, I know how it works. I know why I'm looking for the intercept, for the intersection of the two curves. When I have it again for a slightly different demand and supply equation, I can just put this in, read off where is the intersection, and it's much more convenient. The benefit of things like this isn't to replace my understanding, it's to make the calculation part easier. Any questions on this? I think this is fairly convenient. So, I've been asked to introduce a little bit of Excel if you haven't really used spreadsheets before. Let's do the same question in Excel to see that I can do the same thing with a spreadsheet, and you can decide which one's better. So I want to put in my Q values. Let's call it quantity. Let's zoom in here a little bit. Quantity. Let's zoom in so everyone can see what's happening here. And I want to make a column of quantity values. Let's suppose we start with 200, and the next one is 210, 220, and so on. Excel is going to recognize that this is increasing by 10, and if I drag it down, it will keep increasing the next one by 10, 10, 10. Let's go all the way to 600. 600 over there. As soon as I have 3, it notices the pattern, and I can just drag it down. Then the first one is a supply, so let's go with the supply price. Well, now let me put something on top here. Remind myself, what is the function? The supply is P equals Q over 40 plus 10. Let's bold these guys so I can see them clearly. So now I want to input this formula for Excel so it can take this quantity as the Q value and calculate the corresponding P value. So how I do that is I type an equal sign to say that I'm going to use start typing a formula now. The Q value that I want to use is this guy. I want to divide that by 40, and I want to add 10. And it gives me the corresponding price. It used this guy in the blue box, this blue guy, as the Q value. If I select this cell and I drag it down, it copies the formula. For the next one, it uses that corresponding Q value to calculate the price. For the next one, it uses that. So it knows that it's supposed to use the Q value next to the cell where I put my answer. So I don't have to do a lot of work. Drag it down and it fills in using the same formula. This guy was calculated using that Q value. So I have all the price values corresponding to all the quantity values Q. What about the demand? Well, that was the function 8,000 divided by Q. Just for reference, I put it in the top so I know how it's calculated. So I start with an equal. 8,000 divided by the Q value is this guy. Enter. And the corresponding price is 40. Drag it down a few times. Oh, it doesn't know how I want to round, so it just guesses 5 decimal places. Here it used the corresponding Q value. Here it used the corresponding Q value, so it's going to calculate the price for all these Q values when I drag down the formula. Now I don't really like the look of this rounding, so I can format it. I can say it's a number, let's say 2 decimal places. That looks a little nicer. Everyone vaguely familiar with spreadsheets? Not at all. Again, I'm not expecting you to be, I'm just showing you something to be aware of, because depending on the other classes you might take in the future, they might use a spreadsheet, they might not. It's good to know that I can do some things with spreadsheets and Google and things like that. Just good to be aware of. Now in Google, I just plotted this very easily. Plotting in Excel is maybe slightly less easy, but it's still fine. I want to insert a scatter plot, and I want lines. Let me just put this guy right next to this, zoom out a little bit. There we go. There's nothing in here yet. I need to tell it what should it be using. So select data, and I'm going to call my first curve supply. What are the X values? That's the quantity values. The Q values are my X values, so I select all of them. Again, this is a very brief introduction if you've never seen it before. I know I'm going fast. What are the Y values? all the price values for the supply. And okay, so there it has the straight line from 200 to 600. Now it doesn't mean much until I include the demand as well to see where they intersect. So let's add another one here, call it demand. X values are the quantity values, the Q values, all the way to 600. The Y values are the demand P values. Drag them all, select them all. Let's see if I did that correctly. There I go, that's my demand function, demand curve and supply curve. And I can look where do these guys intersect. It seems like they intersect around 400 with a price of 20. Now I can go to my table and say, well, around 400, oh yes, the price values are the same. So this guy confirms that this is where they intersect. It's the Q value that gives me the same price value. So the graph might not look as nice as the one in Google, it's up to you. But I have the benefit of looking at a list of values that I can compare. For a price, for a quantity of 280 units, my supply is $17 for the corresponding price, and for the demand equation is $28.57. So I have a little bit more information using the spreadsheet. Does everyone have a rough idea of what I'm doing? I'm not expecting you to reproduce it at all. I think the only thing that I want to take from a lecture like this is to know, oh, I have some things at my disposal to make my life easier. And if I want to, and if I have the time, I can go look, how is this done? We only have a little bit of time. Okay, just to know that I don't have to do everything by hand. Once I understand how it's done, there are more convenient ways to do it. I think number 4 for me is quite relevant. The value of a stock had the following values in a certain year given in that table. So let's suppose I'm interested in investing my money into a certain stock. I tracked it for the last year and saw what its value was for every month, and I get those values. Using a spreadsheet or something like Excel, let's see what is the trend. Did that value grow? How much did it grow? Let's see what it does. See if I can predict what is it going to do at month 13, 14. What do I expect how do I expect it to grow for the foreseeable future? So let's make a list here of month values. Month 1, month 2, month 3. I can keep going, but as soon as I have 3, Excel will recognize the pattern that I'm just increasing it by 1. And I can drag it down to make all my months. Let's zoom in again a little bit. Then the other column is the value of the stock. Now, there's no pattern here. I'm trying to figure out what the pattern is. So I have to put them in one by one. 75, 67, 54, then 60. Make sure I'm doing this right. 70. Month 6 is 77. Then 65, 88, whoops, 80. I keep missing the 80. Month 9 is 80, then 85, 96, 95. So just looking at the numbers, it does feel like the value has gone up. But without some sort of visual representation, something graphical that I can see, oh, this is how much it grew. It doesn't help me that much. I have limited values, but let's see if we can plot this to see what it does. Insert, scatter plot, and I just want the points. Let's put it over there. There's nothing in here yet. Right click, select data. Let's add. Give a name, I don't really care, value. The value of the stock is what I'm tracking. The X values, that's the month values, number of months. The Y values, that is all the value of the stock, the corresponding to the months. Okay, okay. So that's how the value of the stock changed as the year progressed. Now I see there is a growth. It's hard to say. There is some fluctuation due to factors that it's hard to predict. Let's see if we can get a straight line that tries to predict how the value of the stock is growing. So Excel has that built in. I select the points, right click on them and say add trend line. I want a linear function, straight line function. There are other options. I want to predict 3 months in advance. So my forecast I can put in on 3. And I want to see what is the equation. So I check this display equation. So I can see what is the straight line equation that best predicts the growth of this stock. Let me just give it a nice little color. Let's go with red. Let's make it a little thicker. Maybe 2 points so I can see it. So there's the equation. And this is the straight line, this red one is the straight line that best describes the growth or the trend in these values. Now there is some math behind this. It's called the least squares fit. And you can do it by hand if you really want to, but it's all built in. And it's outside of the scope of this course at least, to find this best equation, this best straight line. It's built in, there it is. Now I can use that to at least predict what do I expect following this red line. What do I expect will be the value of the stock in the next few months? So let's say here, linear prediction for month 13, 14, and 15. There's my straight line equation that tells me how the stock is probably growing. So I want to put it in as a formula. So an equal sign. Scroll up a little bit. Drag this guy, whoa, too much drag. Drag it down so I can see both. So I want to say 2.9371 times the x value is the month value, this month, plus 56.909. And that is the predicted value of the stock at month 13. I can drag down, copy this formula. This one uses the corresponding month value in the equation. So it seems like if it's following this trend, around month 15 it's going to reach the $100 mark or whatever. Now it's not a guarantee, it's just a prediction. The market could crash, I don't know what's going to happen. But at least it gives me an idea for how this is steadily growing. And of course the more history, the more information I have, maybe the past 5 years, will give me a much better idea of how this is growing. I have limited information here. But there are ways to make sort of educated guesses and predictions. What if I say, well, maybe this isn't going to be a straight line, might have some bend in it. I know about quadratic functions, so let's try and fit the best quadratic function through these points. Trend line, quadratic function is a polynomial of order 2. It has an x squared, that's the order. I want to go 3 months ahead again. I want to see the equation, so I check that box. Let's make it what color?
Oh, okay.
Orange was first, let's go with orange. Let's go with a darker orange. Let's go with 2 points so I can see the thickness of the line at least. So hopefully we can see that line, the orange line. It has some bend in it. Now it's just using these points and saying this is the parabola, the quadratic function that best fits this information. It attempts to minimize the little errors that it's making every time. And this is the one that best fits in. Now it seems like a slightly more optimistic prediction because this guy is curving up nicely. But I can use that as well to make my prediction. So let's say here, quadratic prediction for month 13, 14, and 15. Let's input the, drag it down a little so I can see the equation. Let's input the formula, 0.4076 times the x value is the month value squared minus 2.3616 times the month value plus 69.273.
It's not time, it's you put it up.
Oh, whoa, you're right. That has to be at times. Is that better? And I copy it down, and it says that according to this line, this way of predicting, at month 15 I'm going to have a stock value of 125. So you can decide. This one's a little optimistic. Slightly optimistic, I guess. If you want to convince your friend to invest in this stock, show him the orange line. Yeah, look how good this is going. Maybe the red one is more conservative, but there's no way to really know which one is best based on the information. So hopefully with this, you see that there are tools to my disposal to make calculations easier. All of these can be done by hand, all of these things, but I don't need to get caught up in the math. Once I've seen what a parabola looks like and how to sketch it, I can use technology to do it faster for me. It's not replacing my understanding, it's just making the calculations easier.